Good afternoon. I'm Engineer Sebastian by name, and I'll be explaining a code in Arduino, which is to mimic the lighting and tone of a siren. Now let's dive into the explanation of the code.
So now let's begin with the first line of the code, which is const int red LED pin equals 6. So the const is a keyword. That means that the value of the red LED pin cannot be changed after its initial set. The int specifies that red LED pin is an integer variable. The red LED pin is the name of the variable. It's the descriptive name indicating that this variable will hold the pin number for the red LED. The 6 assigns the value 6 to the red LED pin variable. So the next line, which is const int green LED pin equals 7, it is similar to the red LED pin, and it declares a constant integer variable named green LED pin and assigns it to value 7. The next line is const int buzzer pin. It declares a constant integer variable named buzzer pin and assigns it to the value 9. The buzzer should be connected to the digital pin 9. So now let's move to the next set of code, which is const int low frequency equals 600. This declares a constant integer low frequency and sets its value to 600. This represents the lower frequency of the siren. The next line, which is const int high frequency equals 1500. It declares the constant integer high frequency and sets its value to 1500. This represents the upper frequency of the siren. The next line, which is const int tone duration equals 200. This declares a constant integer tone duration and sets its value to 200. This represents the duration in milliseconds for which each distinct tone will be played and for how long the corresponding LED state will last. So the next set of code is the void setup. The void setup is a special function in Arduino. It only runs once when the Arduino board is powered on or reset. Under the void setup, we have pin mode into brackets red LED pin, output. The pin mode is an Arduino function used to configure a specific pin's behavior. The red LED pin is the pin number that we are configuring, and the output specifies that pin 6 will be used to send electrical signals out to the Arduino to control an external component. The next line, which is pin mode into brackets green LED pin, output. This configures digital pin 7 as an output pin, same as the next line, which is pin mode buzzer pin, output. This configures digital pin 9 as an output pin. So moving to the next line, we have digital write into brackets red LED pin, output. A digital write is an Arduino function which is used to write a digital value to a digital pin that has been configured as an output. The red LED pin is the pin to write to, and the low sends a low voltage to the pin, which turns off the LED connected to it. This ensures both LEDs are off when the program starts. The next line, which is digital write into brackets green LED pin, low. This turns off the blue LED, the green LED at the start of the program. So the next set of code is the void loop. And the void loop is another special Arduino function. After the setup finishes, the code inside the loop runs continuously over and over again as long as the Arduino is powered. This is where the main siren behavior is implemented. So under the void loop, we have the first siren phase, which is the tone into brackets buzzer pin, high frequency. The tone is an Arduino function that generates a square wave of a specified frequency on a pin. The buzzer pin is the pin to generate the tone on pin 9, and the high frequency is the frequency of the tone to generate 1500 Hz. This will cause the buzzer to emit a high-pitched sound. Note that unlike the previous example, this tone call does not have a duration parameter. This means the tone will continue indefinitely until no tone is called on that pin. The next line, which is digital write into brackets red LED pin, high. This turns on the red LED, which is connected to pin 6. Following, we have the digital write into brackets green LED pin, low. This ensures the green LED is off. The next line, which is delay into brackets tone duration. The delay is an Arduino function that pauses the program execution for a specified number of milliseconds. The tone duration is the delay duration of 200 milliseconds. So the high tone will play and the red LED will be on for 200 milliseconds while the green LED is off. The next line, we have digital write into brackets red LED pin, low. So this turns up the red LED. Following the next line, which is digital write into brackets green LED pin, high. This also turns on the green LED. Then as the delay into bracket tone duration, it pauses for another 200 milliseconds. During this time, the tone continues to play, but the green LED is on while the red LED is off. So the next step, we have the second siren phase. So as the first part of the siren phase explained, the tone into brackets buzzer pin, low frequency changes the tone being played on the buzzer to a low frequency of 600 Hz. This creates a wailing down effect of the siren. The next line, which is digital write into brackets red LED pin, high. This turns on the red LED. Following the next line, which is digital write green LED pin, low. This turns off the blue LED. Then followed by the duration into brackets, followed by the delay into bracket the tone duration, which pauses for another 200 milliseconds for the low, which pauses for another 200 seconds. The low tone continues while the blue LED is on. Then we have the end of the siren cycle, which is no tone into brackets buzzer pin. So the no tone is an Arduino function that stops the tone being generated on a specified pin. This is crucial because the tone without a duration parameter will keep playing indefinitely. The buzzer pin is the pin on which to stop the tone. The next line, which is digital write into brackets red LED pin, low, ensures the red LED is off. And the next line, which is digital write into brackets green LED pin, low, ensures the green LED is off. And the delay into brackets 100 pauses the program for 100 milliseconds. This creates a short silence and dark period between each full siren roll cycle, making the distinct cycles more noticeable. After the delay of 100 milliseconds, the loop function finishes the current execution and then immediately starts again from the beginning, repeating the entire siren sequence continuously. So now let's run the program and see what will be produced using the Arduino board. So I want to run the program, and you have to make sure your port, you select your port which your board is connected to. So let's run the program. Okay, so as you can see, done. Yes. Yeah. So as you can see, it's mimicking the siren. Of course, the one of the LED turns on, then the other one is off, then the other one turns on, and the other one is off, while the tone is being played simultaneously. Yeah. So this is the program which I wrote, and hope you like it. See you in my next video. Bye.